In this video, we will solve two problems in engineering economics under the topic capitalized cost. For the first problem, calculate the capitalized cost of a project that has an initial cost of 5 million pesos and an additional cost of 100,000 pesos at the end of every 12 years. The annual operating costs will be 110,000 pesos at the end of every year for the first 3 years, 130,000 pesos at the end of every year for the next 2 years, and 150,000 pesos thereafter. In addition, there is expected to be recurring major rework costs of 500,000 pesos every 12 years. Assume interest rate is equal to 13%. Now, when we are considering this capitalized cost, let's find the first cost. So it's mentioned there, our first cost is the initial cost of 5 million pesos. Now, as for the maintenance cost, the operation and maintenance, or the OM. So, what are the OM here? So, we have the operation and maintenance here. So, this is our first cost. Let's color the OM as annual operating cost. Here's the 110,000 pesos at the end of every year for the first 3 years. Then we have 130,000 pesos at the end of every year for the next 2 years, and the 150,000 thereafter. So we can see the first two operation and maintenance costs here is in annuity, whereas the 150,000, because of the word thereafter, it will be treated as perpetuity. So we will need to compute for the operation and maintenance considering these factors. So let's write down. We have here operation and maintenance 1. That is the 110,000. Then the 110,000 operation maintenance 2. That is 130,000. Then the operation maintenance 3, and that is the 150,000 pesos. What's the next element for our capitalized cost? For the replacement cost, the RC. So we need to find the replacement cost. Remember that the replacement cost is considered replacement cost if it is the cost at the end of the or that is the expiration. So here for this project, so notice that the 12 years is mentioned here at the end of every 12 years, meaning there is an expiration at every 12 years. So the 100,000 pesos here will be treated as the replacement cost in every 12 years, and as well as the 500,000 pesos in every 12 years. So these two here, 100,000, which is a cost that appears in every 12 years, these are actually the replacement cost. So RC1 is 100,000 pesos. Then RC2 is 500,000 pesos. Okay, so we, in the formula for capitalized cost, this is already direct. Then we can put this in the formula, but this one here, the operation maintenance, they are different because the first one here is annuity, the second one is annuity, and the third one is perpetuity. So let's see the cash flow diagram for this. So this is our cash flow diagram. Oops. Okay, so for year 0, and then we have the first year. The 110,000 is at the end of every year for the first 3 years. So 1, 2, 3. So that is the first 3 years. Annuity. So at the end of every year for the first 3 years. So this is the first one. So the A is 110K. And we will need to, since we are dealing with capitalized costs, we will need to compute the present worth, or the present cost for this. And let's name that as P sub 1 for the 100K. Now for the second one, the 130,000, it says there, at the end of every year for the next 2 years. So for the next 2 years, that will be 4 and 5. So that's the annuity of 130K. And we will need to find the present cost for this. So it will cover the 2 years up to the year 0 of it. So this is the year 0 for this perpetuity. Then from here, let's name that as P2. We will use compound interest to move that for here. And that is our P3. So how many years? And number of years here is equal to 3. Here, the number of annuity is equal to 3. The number of annuity here is 2. Then finally, we have the OM3, which is in perpetuity. So that will be, well, since it's in perpetuity, so you can just have here a broken line. And this is 6, 7, 8, 9, and so on and so forth. So this is annuity of 150K. So in this annuity, we will have the year 0 here at year 5. Here. So our line for this perpetuity is something like this. And then let's have a broken line here. This is our P4, and from this P4 we will have to transfer it from this point up to the present. So this is now our P5. So as for the number of years, N. Number of years N here is from year 0, which is the year 5, that is N is equal to 5. Okay. So we can now compute for the OM, the total OM. So for P1, how do we get the P1? So from this cash flow diagram, we can now solve for P1, and that is in annuity. Present worth of annuity, 110K. 1 plus 0.13 raised to the power of 3 minus 1 all over 1 plus 0.13 raised to 3, 0.13 is equal to raised to 3 minus 1 all over 1.13 raised to 3 times 0.13. So that is 259. 259,726.78. Then we have our P2. So here is our P2. P2 is 130K. 1 plus 0.13, 2. So ratio to 2. And then we have, so this is a deferred annuity, but we will just solve it as separately. Let's change it to 3. So that is 306,949. 306,949. Oh, no, it's not. Because it should be raised to 2. So that is 216. $853.32. And then, oh, by the way, this is our P1. So our P3 is equal to the compound interest. Let's move this upward. So that is 216,853.32 divided by, so using the compound interest formula, so that is 1 plus 0.13 raised to the power of, this one here, raised to 3. So that is 216,853.32, 1.13 raised to 3. So 150,290.23. 150,290.23. So that's how we get the P3. But if we use the deferred annuity formula, so that is 130K, 1.13 raised to how many annuity? So if we're using the deferred annuity here, our M is equal to 2 minus 1, and then the denominator is 1.13 raised to 5. Let's say 5. So same answer, 150,290.23. Okay, so you can use the formula for deferred annuity. Next, let's compute for P4. So P4 is actually perpetuity. Here, P4 is treated as perpetual. So 150K divided by the I, which is 0.13. So 150 is to 3 divided by 0.13. So that is 1,153,000. So 1,153,846.15. Then from this, we can now solve for P5. So for P5, So 1 million, we're going to use here the compound interest formula. 1,153,846.15 divided by the, how many years? 5 years. So 1 plus 0.13 raised to 5. So answer 1.13 raised to 5. So that is 626,261.46. So that is P5. Therefore, our OM total is now equal to P1 plus the P3 plus P5. So what's the total now? So 259,726.78 plus 150,290.23 plus 626,261.46. So 1,036,278.47. Well, let's go to the capitalized cost formula, the first cost. So first cost, the first cost a while ago is 5 million pesos. The OM, so we already have our OM. There's no need to divide it with perpetuity. The only reason why there is a perpetuity in the formula is when the situation is perpetual. So in the problem, the only perpetual operation and maintenance here is the OM3. But how about the 110 and the 130? So we cannot fit into the formula wherein OM over I, because they should be treated as annuity. So what we did here is that we get all three of them into singular OM, which is 1,036,278.47. There is no need to do perpetuity again because it's already solved. The operation and maintenance has already been solved, and this is the answer. So that's what we are going to put here in the formula. The OM is 1,036,278.47 plus the 2 RC. The 2 RC, which is 100,000 and 500,000, which we will see every 12 years. So 100K divided by 1 plus 0.13 raised to 12 minus 1. So that's the formula for the replacement cost. And yes, this is minus 0 because we have 0 salvage value, plus 500,000 minus 0 salvage value, 1 plus 0.13 raised to 12 minus 1. So what's our CC? What's the capitalized cost? So 5 million plus 1,036,278.47 plus we have 100,000 plus 500,000 over 1.13 raised to 12 minus 1. So the answer of minus 1. So the answer here is 6,216,214.24. Let's say this is 25. So 621621425. So that's the capitalized cost for problem number 1. Now let's go to the problem number 2. A company is considering 2 motors for their pump project. Motor A costs 4.5 million pesos with an annual maintenance of 900,000 pesos, life of 4 years, and negligible salvage value. Motor B costs 10,500,000 pesos with an average or with an annual maintenance of 450,000 pesos, life of 8 years, and negligible salvage value. Using annual rate of 6%, compute the difference between the capitalized cost of the 2 motors. So we have 2 motors here and we need to solve for the capitalized cost of each motor. Now for motor A, it has a first cost of 4.5 million pesos. An annual maintenance OM is equal to 900K. The life of 4 years. So N is equal to 4 years. Salvage value here, it says negligible, 0. The I is 6%. Now the question here is, do we have the RC? Will we use the RC replacement cost formula for the formula of capitalized cost? Yes. If the RC or replacement cost is not mentioned, therefore RC is equal to first cost. Why is it that there is a RC in this problem? Because of the mention of the life of 4 years, meaning this motor will be replaced in every 4 years, whereas the maintenance cost here, the annual maintenance, will be treated in perpetuity because it's not for 4 years only. So perpetual maintenance, 900,000. So for the capitalized cost A, that is the first cost, 4.5 million, plus the maintenance OM over I, since it's in perpetuity, 900K divided by the 0.06%, plus the replacement formula using RC is equal to FC, that is 4.5 million minus 0, since we don't have any salvage value, all over 1 plus 0.06, and the life of 4 years minus 1. So that's the formula. So 4.5 plus 900K over 0.06 plus 4.5 million over 1.06 raised to 4 minus 1. So that is 36,644,361.93. So that's for motor A. Now for motor B, its first cost is 10.5 million. So that is 10.5 million pesos with an annual maintenance of 450. So OM is 450K, life of 8 years, and negligible salvage value, SB is equal to 0. The annual rate, I, is equal to 6%. And yes, same with the motor A, we have the RC is equal to FC. So using the capitalized cost formula, CCB is now equal to the first cost of 10,500,000 plus 450K divided by 0.06 plus the first cost minus 0 salvage value all over 1.06 raised to life of 8 years minus 1. So 10.5 plus 450 plus 10.5 1.06 raised to 8 minus 1. So that is 35 million 681,289.96. So that's for motor B. So what's the question again? The question here is, or the required here is, compute the difference between the capitalized cost of the two motors. Therefore, we're looking for CCA. So what is CCA minus CCB? CCA minus CCB is now equal to 36,644,361.93 minus 35,681,289.96. So the answer here is 963,071.97 pesos. Okay. So that's for problem number 2. So that's all for this video. So stay tuned for the next problems for capitalized cost.